Hello, I'm Dr. Martin Kashara and I'm from the University of Wolverhampton. I'm a microbiologist that specialises in working out how infectious things affect people. And we've been living in some very, very strange times indeed, and it's all because of the coronavirus. The thing that's saving the world right now are the vaccines. Scientists all over the world have been developing these at breakneck speed. The vaccines that scientists have been collaborating to produce all over the world come in a few different kinds, but they all stimulate your immune system to react to the same thing. If we look at this model here of what could be a coronavirus, we can see we've got the body of the virus, if you like, or virion. We call a particle of a virus a virion. You can see we've got these bits that stick out. In viruses like coronavirus, these are called spike proteins. All of the vaccines that we use today and are being developed all over the world, even now, introduce this so-called spike protein to your immune response. That allows you to be protected from infection later on when that immune system can do the clever thing that it does and produce antibodies. The first class of vaccines are the viral vaccines. This is the Oxford AstraZeneca vaccine, the Johnson & Johnson vaccine, and also the Sputnik 5 vaccines. These use a genetically engineered virus to get the program to make this spike protein inside your cells. So your cell can be used as a factory to make that protein to allow the immune response to develop antibodies to save you from infection later on. It uses a virus called an adenovirus. These viruses normally in nature are responsible for us getting things like pink eye or diarrhea. But these are special adenoviruses that have been genetically engineered to only be able to get inside your cell, but never replicate again to make you ill. All they are is a simple delivery mechanism to deliver that program inside your cell so the spike protein can be made and your immune system can see it later. It's a very clever way of using nature to actually help us get better or protect us from infection. The next kind of vaccines that we see at the moment are what I'm going to call the fatty vaccines. These are made by BioNTech, Pfizer, and also Moderna. What these do, instead of using a virus to carry the information that allows cells to make this protein later on to show your immune system, they use a sort of fatty bubble. Now, your cells are actually made out of a kind of fat. And if we package the information we need to make this protein inside a bubble of similar fat, what can happen is when the two touch, they can join together and that information can pass inside the cell. The cell's machinery makes the protein and shows the immune response later on. Now, if you want to just see what one of these might look like, you can really do this at home. So what I've got here, I've got a little tube and it's just got some water inside, and at the top I've just put some olive oil. And you could do this in a cup, and really what I'm going to do is make a sort of salad dressing. I'm making what's called an emulsion, because these little droplets of what are actually called lipids are what carry the information inside cells in this vaccine. So all you need to do is put some oil and some water in a tube and give it a really, really, really good shake. And what you're doing is you are emulsifying the two things together to make an emulsion. And we get tiny little droplets of oil. And you can see that those things mix together to make a sort of cloudy solution. So what I'm going to do, I've got a microscope set up here so we can have a look at just what this looks like. So I'm just going to take a little pipette full of this stuff, and I'm just going to put one drop on my microscope slide here. And what we can do, we can have a look at what this looks like down the microscope. The vaccines we're talking about represent new kinds of technology They've been developed by a collaborative effort of scientists all over the world, from molecular biologists to virologists to the epidemiologists that understand infection. They've done this in little over a year, when it would normally take more than 10 years to develop and test a vaccine for an infection like coronavirus. So you saw there those oil droplets suspended in water. Now in the vaccine, they're stabilised so they don't separate again. And inside is the genetic program to make a new protein. That, of course, tells the cell to make the spike protein that your immune system sees later on. The last class of vaccines is what I'm going to call the pretend viruses. These are made by a company called Novavax. What these are nanoparticles that are synthetically produced, tiny little particles, and they're decorated with the spike protein that's been made to stick to the outside. Now, your immune response can see this particle and thinks it's a virus and responds to it just like it would to any virus and protein to allow you to develop an immune response for later to protect you. However, this kind of vaccine, because it doesn't have this sort of infection and it doesn't produce proteins inside cells, doesn't make an immune response as strong as the rest. So what it needs is something we call an adjuvant. This is just really an extra ingredient in that vaccine that makes your immune system work a little bit harder. But I've been talking about the immune response, and I've said that it helps to protect you for later on. The immune response starts with one of these things. This is an antigen presenting cell. They find the coronavirus spike protein and they literally eat it. They then process that protein inside their cell and, through some magic, they then express that on the surface of their cell and they can show the rest of the immune response later on. They show the antigen to this thing here. This is called a T helper cell. The T helper cell then takes that antigen and has to go and show another kind of cell. So they're off to a lymph node. It doesn't just activate other cells, it activates cells like this. This is a cytotoxic T cell. They're viral killer cells. The T helper cell goes to a lymph node and takes the antigen to show what's called a B cell. That antigen is taken into that cell and processed again, and the T cell helps all this to happen inside a lymph node. Now there's something going on here. That B cell changes into something called a plasma cell. A plasma cell makes antibodies. These are what's going to stop the virus infecting our cells later on. So we've seen that vaccines can stimulate the production of what we call neutralizing antibodies. These stick to the important spike proteins of a virus to stop it getting inside our cells and protect us from infection later. It even helps to make cells that can remember that infection for another time. So when it sees it, it can make those antibodies quicker and faster and stop us getting ill. So, coronavirus vaccines, mystery solved. See you later.
To be honest, I wanted to be a fashion designer. That was my main thing because I loved science and I really enjoyed it, but I never felt I was good enough. I think that was my biggest thing, is that I did fine. I got A's, but I still felt like I wasn't good enough. It wasn't my strong point. So I went with what I felt like I was better. I was better at art and creative stuff. So I thought, well, I'm just going to stick with that because I know I can do it. I know I can do it relatively easily. But a lot of it was because I didn't know what roles there were out there for trying to pursue science or something a little bit more academic. there is no real average day, but quite often what I would do as a trainee, I come in and I do actually work as a scientist, so I read my bench and then I go off and try and do my studying, and also I try and do extra training and learning on the benches as well. So I'm actually performing experiments and trying to find out what's causing infection for people, and trying to do background research and learning on the job. Really, I wanted to work for the NHS because I wanted to try and help people, and my role as within the laboratory is sort of helping behind the scenes, which I quite like. So we are making a big difference. I'm helping people get better, finding out what's wrong with them, and trying to find them the best course of treatment. So for me, that's one of the biggest things. But also working in the NHS is the people I work with they're fantastic, and it's really good for support. For me, the best thing about doing an apprenticeship is the fact that I can work as well as study. So I'm earning whilst I'm learning, and I'm learning on the job. So I'm actually learning practical skills for the work that I do, which is fantastic. Working and studying, you have to be very organised with your time. So I try and plan my week, what sort of time I'm going to have, which isn't easy with working in a laboratory or working in the NHS, because things change constantly. But I try my best to organise my time to make sure that I'm efficient in working, efficient in studying, and also getting downtime as well. When I was at school, I wish I knew about my job. I wish I knew that there were hospital laboratories, that people are there actually doing scientific work, and the fact that there is actually apprenticeships to be able to do that, to be able to learn to do that. Being able to do an apprenticeship as a scientist, it means I can work practically, whereas I felt I wasn't very good academically at school. I did fine at school, but I didn't feel like I had the academic skills to progress forward, whereas with an apprenticeship you can utilise more of your practical skills, which I'm very good at, and that's my main thing. And then my colleagues within work and my tutors help me with the academic side to get that background knowledge. So that's one of the best things, and I really wish I knew that at school. My advice to give to young people to work in the NHS is have a little look at the different job roles. Try and see if you can actually go and have a look and see what people do, and see the different, if you find something that you're interested in, whether it's nursing, whether it's science, whether it's accounting, whether it's marketing, whether it's managing, seeing whether you can get into those job roles, and just have a little look and see what people do day to day. That's something that I would really advise. So it gives you a bit of an idea of what roles there are, because there are so many different roles within the NHS, and it'd be great for people to see, great for young people to see what actually goes on, how things work. So that's probably my biggest advice, is just to try and see what goes on in the NHS, see what people do. You have to be relatively creative to do science, because you're having to look at things differently. I'm having to interpret. I'm looking at bacteria on plates, and I'm having to look and interpret and investigate, and quite often you need to have a different sort of mindset to be able to link things together, which I think a creative mindset tends to have a bit more of. And you tend to find that actually a lot of people who are working with me, they're quite creative. They do loads of crafts and those sorts of hobbies. So it does actually go hand in hand, really.
In the NHS, we believe there's a bright future for anyone who shares our values. I'm delighted to be speaking to you today. I'm Abby from the NHS Careers team, and I'm going to give you a quick run through of some key information about health careers. Did you know that the NHS is a whole lot more than just doctors and nurses? We do need lots of those, of course, but there are actually over 350 different job roles in the NHS, and each one is absolutely vital to making sure that patients receive high quality care. The COVID-19 pandemic has shown that a huge team is needed to make the NHS work, and everyone is an important cog in the wheel. Whether you're interested in being able to care for patients in a very hands-on way, or you would prefer to be more behind the scenes, there is something for you. We have apprenticeships, entry-level jobs, training routes, and lots more. We'll make sure your teachers and careers advisors have all this information too, but here are some things to help you start to find out more about careers in health. Have a go at the Find Your Career quiz on the Health Careers website. Click on Take Our Career Quiz and answer a series of statements about your interests, skills and preferences, and the tool will then suggest some roles for you to look into based on the responses you've given. Go to the Explore Roles section of the website, where you'll find a page of information about many of the roles within the NHS. Read about entry requirements, training, salary, working life and more. And find out more about the roles you're interested in. Talk to the people who are doing those roles. Find out more about the route they took and what they enjoy about their job. Volunteer if you can. Seek work experience and have a look online as well for virtual experiences. Look on NHS jobs and see what the employers are asking for by clicking into the person specification. Think about the values from the NHS Constitution. Although the right qualifications are important, demonstrating that you have the right values for working in the NHS is also vital. Think about examples from all areas of your life: home, family, school or college, work, a Saturday job, volunteering, any examples which will evidence that you understand and live those values. You'll probably be asked about these at interviews for a job or a course. If you want more information about anything I've mentioned, then please look on the Health Careers website, and you can also get in touch with our contact centre via email or phone and they will get back to you. Go for it. Believe in yourself. Make your move. Look for that course, apply for that job, and never think that you've closed off doors, because there is pretty much always a way to get to where you want to go to. Thank you for listening.